All right, so here we go. Very first video of the year. We'll start with some basic atomic properties and a little bit about the periodic table. So first thing, hopefully this will look familiar. Kind of went through this during the first week in person, but just as a little bit of review again, basic structure of the atom. So if we look, right, we got basic structure of the atom here, and we have our three basic particles, our protons, neutrons, and electrons. Of course, you have the protons and neutrons in the nucleus, and then your electrons, right, outside the nucleus in these rings here. Remember that we said the rings are energy levels. Energy levels. Okay. So each one has a charge, right? Protons, positive 1, neutrons, neutral, so 0, electrons, negative 1. Protons and neutrons both have a mass of 1 atomic mass unit, and they are both located in the nucleus. Of course, electrons are said to have 0 mass, right? And they're located outside the nucleus. So here is an important part that I did not talk about. For a neutral atom, right, one that does not have an overall charge, the number of protons and electrons will always be equal, right? So if you have 6 protons, then you will also have 6 electrons for a neutral atom. Neutral atom, right? So hopefully that makes sense. Neutral, the charge is going to be the same. So for a neutral atom, protons, electrons, the same. Okay, so ions. What are ions? This is an atom that has lost or gained electrons, giving it a charge. All right, this charge is the result of an uneven number of protons and electrons, so positive and negative charges are no longer equal. All right, so sodium here, if you look, we've got 11 electrons, right? So 11 electrons. This little E with a negative sign, that is a negative sign, just in case you were wondering, in case it doesn't quite look like a negative sign. And you also have 11 protons, right? But then here you are losing an electron, right? It's going away. Now over here, what happens? You have 10 electrons that are negative sign this time, but you still have your 11 protons, right? So because you have not lost or gained any protons, so now if you look, you've got 10 negative, right? 11 positive. So overall, you would have positive 1 still. And so anytime you see an elemental symbol with a positive just like that, right? Or you might see it like this, Na plus 1, where it gives you the specific charge, that indicates that that is an ion and not a neutral atom. So we will see this a whole bunch as we continue through the year. So it's good to get familiar with that. Now, there's a difference between positive ions and negative ions other than their charge. One, positive ions are also called cations. I had a student a while ago who remembered this because positive ions are cations, and she said she had positive feelings about cats. The way I usually tell people to remember this is that the T looks like a plus, right? And positive ions are cations. They have the T in them. But they have lost electrons, right? You end up having more protons than electrons when you lose an electron. So that forms a cation. Negative ions are anions, not anions, but anions. No specific trick to remember this one. And then these have gained electrons. So anytime you're gaining electrons, you're going to have more negative than positive, right? So that means they are going to be negative. They have gained electrons. They are anion. Okay, so now isotopes, right? We talked about ions. Now we're going to talk about isotopes. These are atoms of the same element that have a different number of neutrons. And so if you think back, right, protons have a mass of 1 AMU, and neutrons have a mass of 1 AMU, right? So all the mass that we're concerned with in an atom is coming from the protons and neutrons, right? So if you have an atom of the same element that has a different number of neutrons, it's going to cause the two atoms to have a different mass, right? This difference can also cause certain isotopes to be radioactive, right? As the ratio of protons to neutrons is what determines if the nucleus of an atom is stable. So if we look down here at the isotopes of hydrogen, right? We've got hydrogen as we normally think about it, which is also called protium. All right, 1 proton, no neutrons. Then we've got our lovely deuterium over here. And now we have 1 neutron, 1 proton. This is still a pretty stable nucleus. It's not radioactive. Then we get over here to tritium, right? We've now got 2 neutrons and our proton. Now this one, because the ratio is not particularly favorable, tritium tends to be radioactive. This is also the stuff that is in a lot of the water that is used in the cooling tanks for nuclear reactors, because all that radiation, it's bombarded with neutrons. You end up making a bunch of tritium, and so that tends to be what's in the water for nuclear reactors. It's really not terribly good to be putting out into the environment. So now we'll get into the periodic table. So the info on the periodic table. This right here is what each little square on the periodic table looks like. Some periodic tables have more information, some have a little less, but pretty much every periodic table has these 3 pieces of information. Right? Sometimes the element name isn't on there. They just hope that you know the element names. But for the sake of this video, I will say that periodic table will have these 4 pieces of information. Elemental name, as it says here, hopefully this one is self-explanatory. It is the name of the element. Next, right here, right, this 6, that is the atomic number. So each element has its own atomic number, and the atomic number indicates the number of protons in the nucleus of all atoms of that element. Right? So every carbon atom has 6 protons, no more, no less. If you change the number of protons, you change the element. So, right, atomic number, number of protons. In a neutral atom, you can also say that this could be the number of electrons, right? This is an easy way to remember the number of electrons, because in a neutral atom, number of protons and electrons is the same. Okay, elemental symbol, right? This one right here. It's a 1 or 2 letter abbreviation of the elemental name, right? But not always the English name. So that's why the elemental symbol for some things is different than you might think it should be, right? Like gold. Its elemental symbol is AU from Orium, right? Not gold. So it's not GO, it's AU. Okay. For elemental symbols, the first letter of the symbol is always capital, always capitalized. If there is a second letter, it is always lowercase. You will never have two capitals in a row for any elemental symbol. You will never have two lowercase letters as the symbol for an element. The final thing, down here at the bottom, these numbers, the average atomic mass. Okay, so I don't just say atomic mass, I say average atomic mass, because this is a weighted average of the atomic mass of all known isotopes of that particular element. So weighted average, I'm not sure that everyone knows what a weighted average is. We'll just say that it is an average based on the percent of that particular type of isotope, rather than just a straight average where you add up the masses of all the isotopes and you average them together like that. So it is a weighted average. It is based on the percent of any given isotope, rather than just a straight average. Okay, here is the periodic table. This looks largely like the one I have given you. It has about the same information. The only thing is that on yours, some of these have like A1, A2, A3, so on and so forth. The A's through here. You guys also have, thanks to some very nice person, things like this written above them: +1, +2, +3, plus or -4, -3, -2, -1. So these are all the columns, right, above any column that has a common charge as an ion, right? So that will help you determine what the common charges for ions are. They're on your periodic table, and those are for anything in the column underneath, right? So like everything in this column here, 17 or 7A, right? Everything in this column here has a -1 charge when it is an ion, right? Everything over here, group 1A, with the exception of hydrogen. So hydrogen can be plus or -1. Hydrogen is always the exception for stuff like this. But everything over here, right? Lithium, sodium, potassium, rubidium, cesium, francium, all of them have a +1 charge when they are an ion, right? So that's the extra information that you have on your periodic table that was not on this one as it was shown. Okay, so to break the periodic table down a little bit further, the large breakdown of this is that we break them down by blocks. So there are 4 blocks. Each of them has a 1-letter abbreviation. Over here, S block, the P block over here in red, D block in the center, and the F block down here at the bottom, right? So these are the 4 blocks of the periodic table. And really, they correspond to the subshell in which the outermost electrons are located, right? So don't worry about this too much. We can talk about this later. But everything in the S block has its outermost electrons in an S subshell, right? So that's what the blocks are telling you. Now, looking at this, right, this is a pretty common breakdown of the periodic table. This line is a little different on yours. On yours, it goes something like this, right? Either way is acceptable. I've seen it both ways. This one might be slightly more accurate, but we'll leave it where it is. So as you can see, right, we've broken this down into metals, metalloids, nonmetals. Most times you will even just see people break it down into metals and nonmetals, right? Kind of grouping some of these metalloids in with metals, right? Usually germanium, antimony, and polonium are going in with the metals, and then the rest are going in with the nonmetals. But as you can see, most of the periodic table is metals, right? everything over on this side, except for hydrogen again, because hydrogen is always the exception, is considered a metal, right? So all this stuff that's highlighted here in this nice blue color, that's all metals. All right, the rest of the stuff, non-metals. This will be really important to remember when we start talking about compounds and about bonding, all that great stuff. So to sum this up, all right, things that you should really remember. Ions. They are atoms that have gained a charge because they have lost or gained electrons, right? Their protons and electrons are no longer equal. No longer have the same number of protons and electrons. Isotopes. They have a different mass because they have different numbers of neutrons, right? Most elements on the periodic table are metals, and elements end up being grouped roughly in columns with other elements that share similar properties and common charges as ions. All right, so this is why on your periodic table that I handed you on Friday, you have above those columns +1, +2, on and on, is because all of those share similar properties due to similar sets of electrons or similar numbers of electrons in their outer energy level there. And this means that they will have common charges as ions. And there are some other things that group elements on the periodic table together. We will talk about that later when we talk about periodic trends. But for this video, that's it. Thanks for watching. If you have any questions, please send me an email, or we can talk in person when we get back to class. Thanks.